Okay, so let's take a look and see how the 80%, 85%, and 90% confidence interval look different. Okay, so we did the 80% confidence interval. Let's take a look at the 85% confidence interval. Still the same point estimate, 75.92 is the average length. Now, notice the critical z-score changed here, 1.44. Well, why did the critical z-score change? It changed because I'm taking up more of my curve. Okay, I have a higher confidence level, so I'm taking up more of my curve. So if I'm going to draw my curve, that means 85%, okay, of the curve is taking up. There's my confidence interval. It's taking up 85% of the standard normal curve. So that means that I have 7.5 that's outside my confidence interval on both sides. Okay, so 7.5 is outside the confidence interval. Here's your critical z-score. Okay, and like I said, I always think of the critical z-score as the portion that separates from what's inside the confidence interval to what's outside the confidence interval. So in 85 of the confidence intervals, 85 of them are going to capture the true population mean. So in this case, 7.5 on this side are not going to capture, and 7.5% on this side are not going to capture. So that critical z-score is sort of what separates what captures and what doesn't. So you're doing inverse norm, so that's actually this one right here. This is your critical z-score right here. So you're doing inverse norm of 92.5 because that's all the area to the left over here. You could also do inverse norm of 0.075, which will give you this one. They're symmetric, so they're exactly the same. All right, so I'm still multiplying that by the your standard deviation of your statistic, 0.5 divided by the square root of 10. Okay, and here's your resulting confidence interval. All right, and now the 90% confidence interval is going to do the same thing that you did here. The only thing that's going to change is your critical z-score. Notice how my critical z-scores are getting larger as the confidence level is getting larger. In this case, 90% of the resulting intervals will capture the true population mean or proportion, and so I have 5% on either side. So this critical z-score is either inverse norm of 0.95 or inverse norm of 0.05, okay, because that's separating the standard normal curve or your normal curve of sampling means that's in the confidence interval versus not what's captured in the confidence interval. Okay, all right, so let's just go ahead and try another example. So a certain population of the annual incomes of unskilled laborers has a standard deviation of 1,200. A random sample of 36 results in a mean income of 7,280. Now it says estimate mu with a 95% confidence interval. Now just keep in mind though that when you're doing this, since you're using the normal curve to do this or normal approximation, you do want to make sure that your conditions are met, which is what we'll go into more later in the section. But let's just think about this. Since this is greater than 30, by the central limit theorem, we know that the curve is going to be approximately normally distributed. Okay, so that's number one. And then number two, we know that they're independent. So the population is more than 10 times the sample size. So most likely there's more than 360 unskilled laborers. And so that allows us to use the standard deviation. And it does say that it's a random sample. So our three conditions are met. So we're estimating mu with a 95% confidence interval based on what we just did. So what's our point estimate? So that's our point estimate because that's the mean from a sample of 36 workers. Now the 1.96, where did that come from? That came from our 95% confidence interval. Remember, if I'm doing a 95% confidence interval, okay, it's going to take up 95% of the curve. Here's 95% of the curve that it takes up. I have 2.5% on either end that are outside my confidence interval. So 95 of these sample means right here are going to capture the true population proportion or true population mean. Here's a critical Z, separates what's in the confidence interval to what's outside the confidence interval. Once again, here's your other critical Z, separates what's in and what's out. So with that separation point, you want to do inverse norm of 0.025 or inverse norm of 0.975, because remember it's always the area to the left. That's where that comes from. Okay, and then we also know that our population standard deviation was 1,200 divided by the square root of 36. There's your resulting confidence interval. Okay, so do the same thing with the 99% confidence interval. Go ahead and try that one on your own. The only thing that's changing here is your critical z-score. We're now having a higher confidence level. So we're saying if we were to do this many times, 99 out of 100 of the resulting intervals would capture the true population mean. So that's the only thing that's changing. This would be 99 in here, and this would be 0.01 and 0.01. Okay, so a simple random sample of 100 8th graders in the DC public school indicated that 83% of them were involved in some sort of after-school activity. We want to find the margin of error for a 90% confidence interval. All right, so number one, notice that this one is talking about proportions, not means. So you want to read the question and be able to understand whether we're discussing means or proportions. Since it said 83% of them were involved in some sort of after-school activity, you need to think to yourself, okay, that's a categorical variable, therefore that's talking about proportions, not about means. Now, when we do the margin of error, okay, it's a little bit different. Remember that the margin of error is always going to be your critical z-score times the standard deviation of your statistic. Well, we know what the standard deviation of our statistic is from the previous unit. It's p times 1 minus p all over n. Take the square root of that. So this portion right here of my formula is my margin of error. All right, so the first thing that we need to do is we're finding the margin of error. Are we given everything? Yes, we can find the critical z. We're given the proportion, 83%. We're given the sample size n of 100. So the only thing we need to find is our critical z-score. So in this case, since it's a 90% confidence interval, all right, what we know is that it's taking up 90% of the curve. Okay, and I have 5% of the curve outside the confidence interval on both sides. So I need to get that critical z-score that separates what's inside the confidence interval versus outside. So you can do inverse norm of 0.95, which is all of this area to the left, or you can do inverse norm of 0.05, going to give you exactly the same answer. We know that p is 0.83 and 1 minus p is 0.17. Okay, so we're just going to plug those in. Our critical z-score is 1.644. Our p times 1 minus p all over the square root of 100. Do that calculation on your calculator, and our margin of error is 0.0618. So it's about a 6% margin of error with students that are involved. We're either over or under 6% of the time for the proportion of students that are involved in extracurricular activities. Okay, so what would this look like if we were going to interpret the confidence interval and the confidence level? All right, so in the other case, we just looked at the margin of error. Here, we're going to take a look at what the 99% confidence interval looks like, how we can find it, and how we interpret the confidence level and the confidence interval. Now, you're always going to interpret the confidence interval. Every single solitary time you find a confidence interval, you only need to interpret the level if it's asked. All right, so here's what we know. We know that the proportion from our sample, our point estimate, is 83%, okay? Plus or minus our critical z-score, that's what we have to find. That's using, since we're doing a 99% confidence interval, all right, we know that 99% of our data is within the curve, and then the critical z-score is separating what's inside the curve versus what's outside the curve. So you can either do inverse norm of 0.01 because that's outside the curve here to the left, or sorry, 0.05, or you can do inverse norm 0.995 because if you use this critical z-score, area to the left is the 99 plus this 0.05 that's over here. Okay, and then we're going to plug in our proportions, 0.83 for our standard deviation of the statistic, and we get the resulting confidence interval. Now, notice, take a look at the interpretations. We're 99% confident that the interval from 0.73 to 0.93 contains the true percentage of 8th graders in DC that participate in after-school activities. So that's the interval. That's telling us exactly what the interval means. What does that interval tell us? Now, the next one is the level. Remember, the level discusses the process that was used to find the interval. If repeated many times, approximately 99 out of the 100 intervals will capture the true population percentage of 8th graders in DC that participate in after-school activities. Okay, so let's take a look at our last example. Our last example is finding a sample size. So it's believed that 35% of Republican voters favor Donald Trump as a candidate for the next presidential election. How large of a random sample is required so that the margin of error of the estimate of the percentage of Republican voters in favor of Trump is 3% for a 95% confidence interval? So basically what they're giving you is they're giving you what the margin of error is. So oftentimes statisticians start out with this. They say, okay, we know how much we basically want to be off by. What's our margin of error? How can we figure out how large a sample size we need to get that specific margin of error? So in this case, you just have to remember what your margin of error formula is from the formula. All right, and we know this is our margin of error. We know that our margin of error is 0.03. Now we're going to find that critical z-score knowing that I have a 95% confidence interval. Like I said, if you need to, draw the curve. I know the two proportions. I know that 35% of them voted, okay, versus 65% that didn't, all over the square root of n. So I'm just going to solve this, divide both sides by 1.96, okay, and then I'm going to square both sides. Okay, multiply this side by n, then divide over here to get your answer. Now, in this case, now you're going to have to be sort of careful because a lot of times I'm going to say, don't round. But in this case, you do want to round. So this is 972.22. You're going to always round up because we want the margin of error to be less than or equal to 0.03. If I round down to 972, it's actually going to make the margin of error larger. So in order to get the margin of error of 3% or less, you need to round up. Because think about this, if this is smaller, it makes this whole thing right here, your margin of error, smaller. But if this is smaller, it makes this number here larger, which is going to make your whole margin of error larger. But if you round up, it makes this smaller because I'm dividing by a larger number, and it makes your margin of error smaller. Okay, now we're going to be going over this in the next section. I kind of just briefly discussed this. This was just an introduction to confidence intervals, but just as a reminder, since we're using the normal curve to create confidence intervals, you are going to have to check these conditions, okay? So just as like keep this in the back of your head for next time, what were your conditions? Number one, you have to have a simple random sample. Number two, you need to satisfy the 10% condition to use the standard deviation for both means and proportion. So that's where the population is 10 times the sample size. The sampling distribution of the statistic is normal, so that's the sampling distribution of sample means. That's the central limit theorem has to be normal, or for proportions, that's NP is greater than 10, and N times 1 minus P is greater than 10. Okay, so what to do next? So please make sure you try some of the practice problems. It's really important that you understand what a confidence interval is before you move on to the rest of the unit. So the rest of the unit is just focusing on sample means and sample proportions, but if you have a good understanding of what a confidence interval is, it's going to make it a lot easier. Okay, and this is just what we went over in this section. Go ahead and take a minute to read it.